This is Chapter 8, Number 21. A 5-kilogram block is set into motion up an inclined plane with an initial speed of 8 meters per second. The block comes to rest after traveling 3 meters along the plane, which is inclined at an angle of 30 degrees to the horizontal. For this motion, determine A, the change in the block's kinetic energy, B, the change in the potential energy of the block Earth system, and C, the friction force exerted on the block, assumed to be constant. D, what is the coefficient of kinetic friction? So first we have the diagram drawn out right here. And for letter A, we're trying to find the change in the block's kinetic energy. So A is change in kinetic energy. So in order to do that, you take the kinetic energies equation, which is half mv squared, and you're going to do a change in it. So you would do half mv final squared minus half mv initial squared. You know from the problem itself that it comes to rest at the end, so then that means that velocity at final point would be 0, so this is 0. And you'll just be left with negative half mv initial squared. And you know the mass of the block is going to be 5 kilograms. And initial velocity is 8 meters per second. So you're going to square that, and your answer should be negative 160 joules. And that would be your answer. So for part B, you need to find the change in the potential energy of the block Earth system. So in part B, you're going to do the same thing that you did in part A, except you're going to be using the potential energy equation. So the change in potential energy is equal to mgh final minus mghi. So when you start off initially, you don't have a change in height, so then height initial would be 0, making this part 0, and then the part you'll be left with is mgh final. So mass is 5 kilograms. Gravity is 9.8 meters per second squared. And height would be 3 sine 30. And this comes from the fact that when this triangle is inclined at 30 degrees, so 3 sine 30 would give you the height of this part right here, especially since this change would be 3 meters. And then using that equation, you should get 73.5 joules for your answer. So for part C, you need to find the friction force exerted on the block. So first, you need the total mechanical energy is the change in potential energy plus the change in kinetic energy. So you found this already in part A and part B. So you'll have negative 160 joules, which is kinetic energy, plus 73.5 joules. That will give you negative 86.5 joules. Then total energy expended would be friction force times distance moved. If you rearrange this, you should get over the change in distance, which is 3 meters. That should be, and that's part C. So then for D, you're going to try to find the coefficient of kinetic friction. So go back to this part, and you're going to want to do your forces, your free body diagram. So you have mg going down, with your normal force going up like this. So this part will also be 30 degrees. This will be mg cosine 30 and mg sine 30. So the friction force would be equal to theta times normal force. Normal force this is actually technically mg cosine 30. So then your equation would become theta mg cosine 30 You're going to use what you found in part C, this 28.83 newtons. And then when you solve it out, you should get a coefficient of friction 0.679. And that is your answer. And that was number 21 for chapter 8.